Aldol condensation. In this lecture, I will teach you two important topics. Firstly, I will teach you the complete concept of aldol condensation. Secondly, I will teach you the super easy trick of aldol condensation. So watch this lecture till the end and you will learn something awesome. Firstly, let me teach you some important concepts related to aldol condensation, like alpha hydrogen, dilute sodium hydroxide, and meaning of condensation. Well, consider this organic compound. We know that this is the functional group of aldehyde. We call it main group. Now this is the first carbon attached to the main group. We call it alpha carbon. The hydrogen atoms with the alpha carbon are called alpha hydrogens. Secondly, this is the second carbon attached to the main group. We call it beta carbon. The hydrogen atoms with the beta carbon are called beta hydrogens. So remember alpha hydrogen and beta hydrogen. On the other hand, dilute sodium hydroxide means that it also contains water. We know that water has positive hydrogen ions and negative hydrogen ions. Lastly, condensation means the removal of water. Usually, we heat the reactants in order to remove water molecule from it. Thus remember these important concepts. Now what is aldol condensation? Well, in this part of the lecture, I will teach you the mechanism of aldol condensation. Firstly, I will teach you formation of aldol and then I will teach you aldol condensation. Consider this aldehyde. Remember that in aldol condensation, we take two molecules. So I place here 2. We can see that this is main group and this is alpha hydrogen. I take this one aldehyde and write it here. I write here 1 alpha hydrogen. Now I add dilute sodium hydroxide to it. We already learned that dilute sodium hydroxide contains water. Now this is hydroxide ion which has negative charge. Here the electrons will shift towards carbon and positive charge will appear on this alpha hydrogen. We know that negative charge and positive charge love each other, so they react together to form a water molecule. I get CHO and CH2. This carbon has negative charge. Now I take the second molecule of aldehyde. I write it here. We know that oxygen is highly electronegative. It will attract the shared pair of electron. Hence partially positive charge appear on this carbon and partially negative charge appear on this oxygen. Now this negative carbon will attack on this positive carbon. I take this CHO. I write it here. I take this CH2. I write it here. I take this COH. I attach it to this carbon. I take this CH3, I write it here. We can see that this oxygen has negative charge. We have to neutralize this negative charge of oxygen. We know that there is already water present. Hence this negative oxygen will attack on this positive hydrogen. Hence I write this molecule as it is. I attach hydrogen to this oxygen. Now listen carefully. This molecule contains two functional groups. This OH are alcohol group. Secondly, this CHO are aldehyde group. For aldehyde group, I write ald. For alcohol group, I write ol. So we get aldol. Therefore, we call this molecule as aldol because it contains aldehyde group and alcohol group. Now I will teach you aldol condensation. We know that aldol condensation is the removal of water molecule from the aldol. I write here this aldol. We provide some sort of heat to it. We can see that this CHO is the main group. This is alpha carbon. This is beta carbon. Now listen carefully. The alpha carbon will lose hydrogen and the beta carbon will lose OH. Let me repeat it. The alpha carbon will lose hydrogen and the beta carbon will lose OH. Hence I write here H2O and I write this remaining molecule. Alpha carbon and beta carbon has lost one species each. Here, double bond is formed between them. Now this molecule contains double bond. We write here En. Secondly, it contains aldehyde group. I write here Al. Hence we get enal. Remember this important MCQs. After aldol condensation, we get dash or enal. So this is enal molecule. Here, let me teach you an important question. Why double bond is formed at alpha carbon? Can you guess the answer? Well, it is because double bond is more stable at alpha carbon. Let me repeat it. Double bond is more stable at alpha carbon. Hence, it is therefore formed at alpha carbon. So note it down all these important concepts. Now in the last part, I will teach you the super easy trick to remember aldol condensation. Consider this conversion reaction. We can see that this is aldehyde and this reaction is aldol condensation. Now I write the second aldehyde below the first aldehyde. We know that aldol condensation is the removal of water molecule. Now listen carefully. This alpha carbon will lose 2 hydrogen atoms, and from this molecule, this oxygen is removed. Let me repeat it. This alpha carbon will lose 2 hydrogen atoms, and from this molecule, this oxygen is removed. Hence, I take this COH, I write it here. This alpha carbon has lost 2 hydrogen atoms, I write only CH. I take this CH and double bond. I attach it to this carbon. I take this CH3 and I write it here. Lastly, I write H2O. Hence, this is the aldol condensation. Finally, consider this conversion reaction. Pause the video and try to solve it using the trick. Well, this is the ketone. I write the same ketone below it. We know that this carbon loses 2 hydrogen and this molecule loses this oxygen. I write the molecule CH3 single bond C double bond O CH and I attach this molecule to it. C double bond, this CH3 is bonded to this carbon and this CH3 is also bonded to this carbon. Hence this is the aldol condensation of ketone. Therefore, using this trick, we can easily write the aldol conversion reactions. I hope that you have learned all these important concepts.